Hello, in this video we are going to look at arithmetic and geometric sequences, and we are explicitly going to be practicing using their explicit formulas. As a reminder, an arithmetic sequence is a sequence with a linear pattern, so we are adding or subtracting the same common difference to get to our next term. And a geometric sequence, we are multiplying or dividing by the same number to get to the next term. Now, we do want to focus on the multiplication. So if you do see that the pattern is division, we can always turn that into multiplication. For example, if you can see that we're dividing by 2, that is the same as multiplying by 1/2. If you can see that we're dividing by 4, that is the same as multiplying by 1/4, and so on. So always make sure with geometric sequences, we are thinking about it in terms of multiplication when we put it into our formula. So here we have two examples. It says, given the arithmetic or geometric sequence, write the explicit formula and use the formula to find a sub 8. So in this first example, I can see that it is an arithmetic sequence. I am going down by 5 every time. So D is going to be -5. My explicit formula, maybe I'll write that higher. My explicit formula for an arithmetic sequence is a sub n equals a sub 1 plus d times n minus 1. So what I want to replace is I want to replace my common difference d, and I want to replace a sub 1. I found d is -5, so what is a sub 1? A sub 1 is my first term, which in this case is 100. So my formula would be a sub n is equal to 100, and then my common difference is -5 times n minus 1. Now, I don't need you to simplify this, so this is going to be my arithmetic formula, my explicit formula for my arithmetic sequence. I can leave the n minus 1 just like that. Where that comes into play is now for this second part, when I want to find a sub 8. Now what that's telling me is I am plugging in 8 for n. So if I do that, I'd have 100 minus 5 times 8 minus 1. Now you can choose to plug in all of this into your calculator at once if you would like. Some students might find it easier to simplify this down. So if you wanted to make this 100 minus 5 times 7, you can do it by hand. It doesn't matter. I would take out your calculator and practice, but you should get, when you plug that in, 65. So that means the 8th term of my sequence is 65. If I look at the second example, this is going to be a geometric sequence. My common ratio now is 2, as I'm times 2 times 2 times 2. So my R is going to be 2. The explicit formula for my geometric sequence is a sub n equals a sub 1, and now times r to the n minus 1. So in this case, we still need to substitute a1, and in my case, a1 is going to be 3, the first term in my sequence, and I still need to replace r, which I found to be 2, and the n minus 1 stays there. So now my formula would be a sub n is equal to a sub 1 is equal to 3, and then times r, which is 2, to the n minus 1. Now you might notice that this looks similar to our exponential function where we had our y-intercept and our multiplier, and it is very similar. The big difference is in our exponent we have n minus 1. So then this would be my explicit formula. For me, sometimes I do like to use parentheses, so I might write it as parenthesis 2 to the n minus 1. This is especially important if you have a negative r value, because then as you go through and plug it into your calculator, it'll just work a little better. So I usually like to use parentheses like that, as long as we know that we're multiplying. We can do the same thing now if we want to find a sub 8. That still means I'm plugging in 8 for n, and I'm going to use the parentheses this time. So exponent, I have 8 minus 1. Now, I would recommend, before plugging it into your calculator, I would recommend simplifying the exponent to 7 before you plug it into your calculator, just because I feel like depending on your version of calculator, it may not do the correct order of operations, and know that the 8 minus 1 is all in the parentheses. So I would do that on your calculator. And if you do that, 3 times 2 to the 7th, you should get that the 8th term is 384. So that's one example of using the explicit formula to find a later term. Another example that we could do is, given the recursive formula, identify the explicit formula, or write the explicit formula. So just like before, if I am writing my explicit formula, I have a sub n is equal to a sub 1. Now, in this case, this is going to be an arithmetic sequence because we have this minus here. So I know it's going to be arithmetic. So my explicit formula, a sub n equals a sub 1 plus d times n minus 1. And we have to identify two things. We need a sub 1. Well, my formula tells me a sub 1 is 8. And then I need to identify r. And my formula also tells me that r is going to be minus 12. So when I write my explicit formula, I have a sub n equals a1 is 8. And then now plus d, which in my case is minus 12 times n minus 1. And this is my explicit formula. The second example is going to be geometric, because now we are multiplying times 1/2 instead of adding or subtracting. So that's a common ratio. So for this formula, I have a1 is a sub n is equal to a sub 1 times r to the n minus 1. So I need to find a1, which again, my recursive formula gives me a1 is 13. And I need to find my common ratio, which is going to be 1/2. That's what I'm multiplying by. So now when I write this in my formula, I would have a sub n is equal to a1 is 13. And then times, I'm going to use parentheses, times 1/2 to the n minus 1. And that is my explicit formula. So the recursive formula is nice because you can find both a1 and r from the recursive formula just listed in what they give you. The last thing that we are going to talk about is word problems. So with these word problems, we have to identify what type of sequence it is and then be able to solve. So here you are watching the EHS marching band enter the field at a football game. There are 5 students in the first row, 9 students in the second row, and 13 students in the third row. If this pattern continues, how many students will be in the 12th row? Well, in this case, I'm just going to list out my sequence. So there are 5 students in the first row, so 5 is my first one. 9 students in the second row, so 9 is my second. And 13 in the third row, so 13 is my third term, etc. We want to know how many students in the 12th row, so eventually I am finding a sub 12. So, two things we need. We need our common difference or our common ratio, depending on what type of sequence it is, and we need a1. Well, I can see a1. a1 is my first term, that's going to be 5. And now if I look at my sequence, this is going to be arithmetic because I am adding 4 in each row. So my common difference is 4. So my explicit formula is a sub n equals a1, which is 5, and then plus my common difference, plus 4, times n minus 1. The nice thing about an explicit formula is now, if I want to find how many are in the 12th row, I can just plug in 12 for n. I don't have to worry about going through and plus 4, plus 4, plus 4, plus 4, 12 times. So now what I can do to find a sub 12, I'm just plugging in 12 for n and then plugging that into my calculator. So now I replaced n with 12. You can plug all this in your calculator, or if you want to simplify it first, you could do 5 plus 4 times 11, and you end up with there are 49 chairs in the 12th row. Or students, I guess. Let's look at the last example. A video you posted to YouTube had 5 views on the first day. So 5 on the first day, 10 views on the second day, 20 views on the third day, etc. If this pattern continues, how many views will be on the 8th day? So eventually we are going to be finding a sub 8. So first things first, let's determine what kind of sequence do I have? Well, from 5 to 10, I am multiplying by 2. From 10 to 20, I am multiplying by 2. So this is going to be a geometric sequence with r equal to 2. And my A1 is going to be 5. So for my explicit formula, A sub n equals A sub n is going to equal my A1, which is 5, and then times 2, my r to the n minus 1. So now the last thing that I have to do is I have to plug in. If I want to find a sub 8, I can plug in 8 for n. And as I mentioned before, for these ones, I would simplify this to be the 7th power, just so that your calculator does the correct order of operations. And when I do that, I get that there are going to be 640 views on the 8th day.